Welcome to circular stairs. So this is the first intro where we have given a radius to a stair. So let's see what we have given to us here and the kinds of things that we need to find out. We can see there's a drawing of a stair. They are all supposed to be the same. So this is just my imperfection in drawing. Of course, the treads are supposed to be equal to one another. So specification. Okay, so we have a total rise of 2,900. We have a desired unit rise of 180, so it'll be somewhere around there. A stair width of 1,550. The stair itself turns 195 degrees from the time you enter to the time that you exit the stairs on the next level. We have an inside stringer radius of 750, headroom of 1995, upper floor construction of 350. Okay, so let's write some of these things in first. Now, of course, we have what we're trying to figure out, but let's not get there yet. Okay, so total rise. I'm going to leave space up here on my piece of paper to draw out the set of stairs in an elevation view, just like a straight stair. That's going to help us with the with the finished opening length later. But stair width, 1,550. We can pop that in here. That's from here to there. We know that. Stair turns 195 degrees. I want to write that down. Inside stringer radius, so that's from the center to the radius, that's 750. So already by looking at that, later for our outside radius, we can add our inside radius plus our outside radius. That's just something I like to do right away so I don't forget. So 750 plus 1,550 gets us 2,300. And that's the outside radius. Headroom will draw into our other drawing and the upper floor construction as well. Cool. So I'll leave a little bit of space for my drawing here. Let's walk through. So number of risers, that's just like a straight stair. We take the total rise of 2,900 and divide it by our desired unit rise. 2,900 divided by 180 gets us 16.1, and we're going to round down to 16 because that's going to get us the closest to our 180. So that means we're going to have 16 risers. Great. So at this point, I can now make my drawing because I like to make it with my actual steps, like the actual number of them, not just a random number. Because if you ever have to count out what you did or what you're trying to figure out, it's nice to have the real numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It doesn't need to be super beautiful, but good enough that you can kind of see what's happening. There we go. There's our stair. And on the other side, we have our upper floor construction. So now we can pop in a few extra numbers. Our total rise, let's draw it in red. 2,900. Our nosing line, it's always a good one to draw in. And again, of course, it's supposed to touch the actual nosing of the stair. It's a hand-drawn drawing, so it's not going to be perfect, but it definitely tells me enough of what I need to know. So for later, we know that these points are going to be our A and B. AB for our finished opening, and BC or drop to line of flight. To line of same thing, but people call it differently. We have our headroom. of 1995 and our upper floor construction of 350. Our BC, or drop to line of flight, is our headroom plus our U of C, upper floor construction, right? It's the B from the very top of the finished floor on the upper level to our C on the nosing line. So 1995 plus 350 gets us 2345. And that's BC. That's something to remember for later. Excellent. Have you drawn in all the things? I think so. Wonderful. Now let's continue. Next, we want to find our unit rise. Same thing as our as a straight stair. So same total rise divided by now the amount of risers that we have to find out the actual unit rise. Pop that into the calculator. Should be pretty close. 181 point, let's call it 3. That's a unit rise. That's also one to remember for later. And we can pop them in here as we go. So we've got 16 risers. We've got 181.3. Now, number of treads. If we have 16 risers, we will always have one less tread than riser because the stair starts with a riser and it ends with a riser. So I always mark myself an arrow down just to remember. So that's going to be 15. Oops, wrong color. 15 treads. Okie dokie. Inside stringer unit run. Okay, let's go there next. Inside stringer unit run. That's what we're trying to find out. Looking at this, they're circular stairs, right? So it's going to have a lot to do with circles and finding the radius and circumference of things. So we have a radius given from the center to our inside stringer of the 750. So first thing we want to do is find the circumference of our inside circle. Once we have that, we can use our ratio and proportion to find the actual length of that stringer. Okay, so first, circumference inside stringer. As always, it's 2 pi r. And it's 2 pi r is our 750. Pop that into the calculator. 2 times pi times 750. 4712. Yeah, and we'll just keep it there. Perfect. Okay, so that is the circumference of the entire little circle, right? So now if we want to find just the portion of the circle that is part of our stairs, well, we know that our stairs turn 195 degrees, and we know that a circle has 360 degrees. So if we want to do some ratio and proportion, we can go partial over full. So we can use our partial 195 degrees of the stair, right, the whole length, over 360. That's the full circle. And we want to find out how long that is, right? We just figured out the circumference of the full circle, right, of the 360 degrees. So this way we can figure out how long this is of just 195 degrees. So ratio and proportion, cross multiply and divide. 4712 times 195 divided by 360 gives us 2552. Perfect. Maybe we'll put the 0.3 in there. Okay, awesome. Now, that is the circumference of the stair of the inside. So from here, can we figure out how long our actual inside unit run is? Yeah, well, yes, we can. Inside unit run is the circumference of our stair, of just what we have, divided by the number of treads. 2552.3 divided by how many treads do we have? 15. That in the calculator, divide by 15 gets us 170.2. So that means the inside run, right here, the run on the inside of the stair is going to be 170.2 mils. Awesome. Now, radius of the outside stringer, check this out. Inside radius plus the width of the stair gets us the radius for the outside stringer. So we already figured that out. We can just pop that in there. I will write it here. Just so that it's here. We have the inside radius plus our stair width. So that's our 750 plus our 1550 gets us our, double check one more time, plus 1550 gets us our 2300. Awesome. So that is the outside stringer radius, right? From the center all the way to the outside stringer. Now, can we figure out, and maybe I'll pop on the next, yeah, we'll stay here. Next, we want to find out the outside stringer unit run. So basically, we're redoing this entire tiddly bit here. We're going to figure out our circumference of the entire circle on the outside. And then we're going to do ratio and proportion to find out the length, basically, of our arc that our stair runs. And then from there, we can figure out the unit run by dividing it by the number of treads that we have. Okie dokie, so we have the circumference of our outside stringer. Again, 2 pi r, popping in the number 2 pi r, so 2300 times 2 times pi. 14,451. Awesome. Now, to find out the circumference of our stair, we can do a ratio and proportion again. We'll do partial. This up a little bit. There you go. Partial over full, which means same as above here. We have 195 degrees in our stair over the 360. That's the circumference of a full circle, the amount of degrees that we have in there. Equal to, well, we want to find this. And we did just find our circumference of the outside stringer. Now again, ratio and proportion. 14,451 times 195 divided by 360. 7,827. Maybe we'll round it up. 7,828. There we go. This is one to remember. That is the circumference of our stair if you measured it along the circle along the outside stringer. Now, can we figure out how long each tread is on the outside, the unit run? Yes, we can. So unit run outside stringer. We have the length that we just figured out, 7,828 divided by our 15 treads. 7,828 divided by 15 gives us 521.9. That's the unit run on the outside stringer. Pop that in here. Awesome. I will pull out an extra piece of paper and I'll leave it here so that we can still see our drawing. Okay. Alrighty, what's next? Degrees turn per tread. Well, how many degrees do we have in our stair? We have 195. How many treads do we have? Well, we have 15. 195 degrees divided by the number of treads that we have will get us the degrees turned per tread. That is probably one of the easiest ones in here. Lovely. Degrees turned by finished opening. Okay, well, this is a two-part question. First, we need to find our finished opening. And how do we find that again? Well, our finished opening is AB. In this AB and BC triangle, BC being the addition of the headroom and our upper floor construction, this one directly correlates to our unit rise and unit run. So we can do ratio and proportion to figure out AB. And that's why we draw it out on the flat like this, because it makes it much easier to visualize. So the way she goes is unit rise. And here, because we're looking for the opening, we're looking to work with the outside stringer unit run. So outside stringer unit run equals BC over AB, right? Unit rise is at the top, rise here, and then the run and the finished opening at the bottom. So we do have three of these numbers and we're trying to find AB. So let's find them again. Our unit rise, 181.3. Over our outside unit run, we just figured that out. 521.9 equals our BC, the 2345, headroom plus our upper floor construction. And well, the AB we're trying to find out. Let's pop that into the calculator again. Cross multiply and divide. So 2345 times 521.9 divided by 181.3. 6750. That is our finished opening. This right here. So on the drawing, the finished opening goes to here. That's why it's drawn in a little bit darker. Usually in circular stairs, the last couple of steps will kind of be open, if that's how you want to call it. Excellent. So now degrees turned by our finished opening. And I'll just call it AB. Often it can also be called FO for finished opening. We can do some more ratio and proportion here. So we want to find the degrees of our opening. So we're going to do our degrees and basically the length. Those are the things that we're trying to compare. So the degrees of our opening, and that will be the length of our opening, right, that we just figured out. And it's going to equal to, well, the degrees of our whole stair, so the 195, over the length of our, like the circumference of our stair on the outside. So that's the number we found here. The 7828, the circumference of our stair over the 195 degrees. So 7828. Pop that in here. 7828. Here we go. And now we just, again, cross multiply and divide. 6750 times 195 divided by 7828. Gives us 168 degrees. So while the stair, the entire stair, turns 195, the finished opening only turns 168 degrees. And that's how it goes. So there's lots of comparing of ratio and proportion of circles and degrees and lengths. So it's always good to find the inside radius. You want to find the width of the stair. That way you can find your outside radius. If the question says, well, what is the unit run at the center of the stair? Well, you would just add half of your stair width number and then do the same math that we just did. For our finished opening, it's really important that you just draw this out again. Draw it on the flat in that elevation view, pop in all the numbers you have and what you're trying to find, and then it'll be much easier. And same here, if this isn't given to you, you can just draw it. It doesn't have to be beautiful, it doesn't have to be perfect, but it'll definitely make your life easier. And one more thing to remember is how to calculate the circumference.